So I'm recording this video to help you understand how to uh, solve the example based on indexing. And this in this video, typically the indices are given, and we have been asked to draw the direction based upon those given indices. So this video will hopefully help you to understand the indexing more deeply. Okay. On this slide, we will draw direction corresponding to the indices given here on this slide. Okay, and for drawing the indices, or sorry, for drawing the directions, you have to first construct a coordinate system like this, and then you draw a unit cell, a cubic unit cell, and hence this will be for BCC and FCC, not HCP. You can also draw a line with me. If you want to draw a line along with me, then just pause the video and on your book, draw a picture like this with three axes mutually perpendicular to each other and a cube inside that coordinate system. Okay. So let us begin. So first given indices are 100, and as they are enclosed within square bracket, they are referring to a particular direction. Okay. So the first index inside the square bracket gives the information about x-axis, or how much of the edge length along x-axis is spanned by that direction, okay, or the length of projection on x-axis. And what we'll do is now we have to draw this direction 100, and starting from the origin, you have to simply travel along x-axis, then y-axis, then z-axis by a length equal to the projected length. Okay, so 1 is the first index. That means we have to travel the entire unit cell edge length along x-axis. So let me draw the edge lengths here. So the edge length along x-axis is A, and along y-axis is B, along z-axis is C. So those are the edge lengths along x, y, and z axis. Now 1 represents we have to travel entire edge length along x axis. So starting from the origin, you have to travel entire edge length A along x axis. Then 0, then you don't have to move further, or you don't have to travel anything along y axis and anything along z axis. So this is the required direction. This direction is 1 0 0 direction. Similarly, second 1 bar is 0 0. Let me erase. Hopefully, you will be able to remember those age lattice parameters. Okay. So you can just pause the video, and if you want to try out, you can just try out the second direction 1 bar 0 0. So just for the reference, I am drawing a unit cell which is behind this given unit cell. It's not necessary for you to draw it. I am drawing it here for clarity. So 1 bar is negative x. So we have to travel 1 unit edge length along negative x direction. So that is this much along x, negative x direction. So this is the required direction. So this is a 1 bar, nothing along y because second index is 0, nothing along z because third index is 0. Okay, so those are the first two directions. Then third direction, so you can pause the video and try this yourself. 0 1 0, so only second index is non-zero, and second index indicates the amount of movement along y-axis. So you have to travel entire edge length along y-axis. Okay, so starting from origin, we will go one unit cell edge length along y-axis. Okay, so it should actually go inside the edge of that unit cell. Yes. So that is the required direction. We have to travel nothing along x, nothing along z. So this direction is 0, 1, 0. Then 0, 1 bar 0. So for this, I am drawing a unit cell on the left of the given unit cell. It's not necessary for you to draw it. Okay. Then so 0, 1 bar 0 means one unit cell edge length along negative y direction. So you have to go that way. So this is the required direction. 0, 1 bar 0. The procedure that we have seen is for if the direction is given and then you are supposed to find out the indices. So we are doing exactly opposite. The indices are given and then we are drawing the direction based upon the given indices. Okay. Then 0, 0, 1. So only z index is non-negative or not, sorry, non-zero. So we have to move one unit cell edge length along z axis. I'm sorry, should be drawn properly, coinciding the edge length. As I am doing with my mouse, I'm not able to draw it correctly. Then, so this is the required direction 0, 0, 1. Okay. Then finally 0, 0, 1 bar. So we have a unit cell below the given unit cell. Okay. Again, it is not necessary. So I'm drawing 0, 1, 0, 1 bar. That's it. One unit cell edge length in negative z direction. So 0, 0, 1 bar. So those are the 6 directions on this page. Then the next slide, 1, 1, 0. So let us draw 1, 1, 0 direction. So now two of the indices are non-zero. So first two indices are non-zero, x and y. So starting from origin, so that is the origin. Starting from origin, again the sequence is not important. I can move one unit cell edge length along x-axis and from that I will move one unit cell edge length along y-axis, or we will do both ways. Okay, so 110 means one along x and one along y. That's all it means. So I can follow any sequence. So first we will follow for x and then y, and later on we will follow y and then x. Finally we will get the same direction. Okay, so let us go one unit cell edge length along x, and then from here we should move one unit cell edge length along y. Sorry, y. So we reach here and then connect this point with the origin. So this is the required direction. So this is the direction 1, 1, 0. Okay. So now let us follow opposite sequence. So we will do x, y first and then x. Let us see what is the difference. One unit cell edge length along y direction. We reach here, and then one unit cell edge length from this point towards positive x direction. So again we reached at the same point. Connect this final point with the origin, and this is the required direction 1, 1, 1. Okay. Then the second direction 1 bar 1, 0. So let me erase this. You can just pause the video and draw it yourself. Then this second direction 1 bar 1, 0. So I have a unit cell behind the given unit cell. So this is just for the clarity. Again, it is not necessary for you to draw it. Okay, 1 bar 1, 0. So again, this is the origin. 1 bar means we have to move one unit cell edge length along negative x-axis, and from then we have to move one unit cell edge length along positive y-axis. So let us do that. So one unit cell edge length along negative x-axis, and from this point we have to move one unit cell edge length along positive y-axis. So that is the point. Connect this with origin. We get the required direction. So this green direction represents the required direction. Sorry, we have 1 bar, 1 0. So that is the required direction. Then next is 0, 1, 1. Right? So which means we have to move 0 along x or nothing along x, 1 unit cell edge length along y, 1 unit cell edge length along z. So 1, so what this means is 1 y, 1 z. You can follow any sequence. So first y, then z, 1 unit cell edge length along y, and from this point 1 unit cell edge length along z. Connect this point with the origin. So this is the required direction. 0, 1, 1. 0, 1, 1. The required direction. Similarly, in opposite sequence, if you go z first and then y, so z first and then y, we will reach the same point again. Okay, hope you have understood this. The next 0, 1 bar, 0. So nothing along x, nothing along x, and 1 unit along negative y, and 1 unit along z as it is positive z. So let me have a unit cell adjacent which is on the left of the given unit cell. So 1 unit along negative y direction, and from that point 1 unit along positive z direction. So this is the required point. Connect this with origin. This gives required direction. 0, 1 bar, 1. That is the required direction. Even if you follow the opposite sequence, 1 unit along z direction first, and then from this point 1 unit along negative y direction. So this gives 0, 1 bar, 1. Okay. Similarly, you can try out the remaining two direction 101 and 101 bar. I will give the solution. So 101 comes out to be like this. So one along x and one along z. So one along x and one along z. We will reach here. So this is the required direction. Sorry, this is the required direction. And then 101 bar. So 1 unit along x, 1 unit along x, and 1 unit along negative z. So negative z, that is the point. So sorry, using color. So this is 101, and this is 101 bar. Okay, hopefully you understood how to draw them. Then let us draw planes. So 100 plane, 100 plane. So plane is different. Drawing planes is different. It means that the given plane. So 100 means that the given plane intersects x-axis at a point which is away from origin by a distance of 1 unit cell each length. So all we have to right now is locate that point first. So this is the point which is at a distance of 1 unit cell each length from the origin, and then the plane does not intersect y and z axis. That means plane is parallel to yz plane. Okay, and hence the required plane is this plane. So this is the required plane. So this is the required plane. Don't forget to hatch it. This is the required plane. So you can see that this plane intersects x-axis at a point which is 1 unit cell edge length away from origin, and it does not intersect y and z axis. Okay, so we are done with this. Hopefully you understand. Uh, then the next plane 1 bar 0 0. You can pause the video and try this yourself. 1 bar 0 0. So the plane intersects x-axis, negative x-axis actually is 1 bar. So the plane intersects negative x-axis at a point 1 unit cell edge length away from origin. So this is the point that is 1 unit cell edge away from origin, and the plane is parallel to the y and z axis or yz plane. So this is the required plane. This is the required plane. Okay. So again, there is no need to draw a plane like this. I will explain to you later on. 0 1 0. So this plane intersects y-axis at a distance of 1 unit cell edge length away from origin. So 1 unit cell edge length away from origin towards y-axis, and then this plane is parallel to x and z axis. So let me erase this plane. So the required plane is this plane. So this is the required plane. Similarly, you can pause the video and try this 0 1 bar 0 yourself, and this will be simply this plane. So this plane is 0 1 bar 0, which intersects y-axis or negative y-axis at a distance 1 unit cell each length away from the origin. So this distance is 1 unit cell each length from the origin. This is the required. This is 0 1 0, and this is 0 1 bar 0. On the same lines, try out the last two planes. Okay, I am leaving this for your homework. So it's already solved 1 bar 0. Okay, then 1 1 0. 1 1 0 plane. So x intercept 1, y intercept 1, z intercept 0. So this plane intersects x-axis at a distance of 1 unit cell each length away from origin. So this is the point. First we look at all the points of intercept on x, y and z axis. Then this is the point of intercept, or this is the y intercept of this plane. But this plane does not intercept z axis. So it is parallel to z axis. So this is the required plane. Sorry. This is the required plane. Okay. Then 1 bar 0. So let me erase. Find out the intercepts first. 1 bar 0. Negative x, 1 unit cell h length. Negative y, 1 unit cell h length. Then required plane is the plane that passes through those 2 points and parallel to z axis. So that is the plane. So you can try out the other planes. I'm leaving them for your homework.